video we learn how to balance chemical equations. In a chemical equation, you usually show a chemical change. So for example, in this case, let's say that magnesium reacts with oxygen to produce magnesium oxide. Anything before the to produce are the reactants. So the magnesium and the oxygen are the reactants. And then the magnesium oxide is the product. In general, in a chemical reaction, the reactants are the stuff that reacts, that is shown on the left. And then the stuff that is produced is shown on the right. According to the law of conservation of mass, you cannot make more than what you have, and therefore you need to balance an equation. Let me show you. If we were to show the magnesium reacting with the oxygen, magnesium is a metal, so we write it as Mg. Oxygen is a gas, so we don't usually say just O, it is O2. And same thing with other gases like hydrogen, nitrogen, and so on. And if you notice, it's magnesium reacts with oxygen to produce, so I put an arrow for the to produce magnesium oxide. Now you would have to compute the formula of magnesium oxide as Mg2 plus, it's an ionic compound, and 2 minus. Therefore, the formula will be MgO because the 2 and the 2 minus get cancelled. So we get MgO. What we notice though is that we have 1 Mg here, 1 Mg here, but we have 2 oxygens and only 1 oxygen here. This cannot happen because where did the other oxygen go? You have to have what is known as mass balance. You cannot just simply lose something and not account for it, or you cannot simply make something and not be able to account for it. So what we do is use coefficients to show a balancing to do that. In a chemical equation, here's another example. This is methane. It's reacting with the oxygen to produce carbon dioxide and water, and the coefficients are before each of these guys. Notice where the coefficients are, they're before the formula. You cannot create or destroy atoms, and so you have to conserve atoms. So if you had 1 magnesium on the left hand side, you have to have 1 magnesium on the right hand side. If you had 2 oxygens on the right hand side, you have to have 2 oxygens on the left hand side, whether it be 2O giving O2. So these subscripts indicate that there are 2 oxygens. This coefficient also indicates that there are 2 oxygens. Let's say if you have 2O2 like this guy, then that means you have 4 oxygens. 2 times 2, 4 oxygens, just for an example. Some of the things that are there, you have the reaction arrow, which I showed you. You have the states of matter that are shown too. So for instance, let me show you this guy. So the reaction of propane, C3H8 with oxygen, 2 forms. So anytime you see the 2 form, there's a arrow. It's giving you carbon dioxide and water. So you put a plus sign between those guys. Now propane is a gas, oxygen is a gas, carbon dioxide is a gas, and water is a gas. So we show the states like this: solid, liquid, gas within brackets. The next step is to do sort of the computation. There are 3 carbons on this side. Look at the number of carbons on this side. There's only 1. So to rectify that, I'm going to put a 3 a coefficient in front of the carbon dioxide. This 3 belongs to both this carbon as well as this oxygen. So what we have effectively done is we have 3 carbons and 6 oxygens. 3 times 2, 6 oxygens. So 3 carbons, 6 oxygens as soon as I put that 3. Yeah, to continue. There are 8 hydrogens. On this side, you only have 2. What is the common multiplier between 2 and 8? If I put a 4, then maybe I have 8 because 4 times 2 is 8. Then we have to deal with our oxygen. Right now we have 2 oxygens, but how many oxygens do we have here? We have 6. Plus, we have 4, 10. So we put a 5 here to make it 10. You can see this sort of visually here once we have figured out the coefficients 1, 5, 3, 4. It's always going to be whole numbers that you're going to use, and you can figure it out. Try and do the magnesium plus oxygen gives you MgO, and then go on to the balancing worksheet and try to do many more examples. And then the worksheet is due in class on